So in last class, we have discussed about that what kind of services SDA Fabric is going to provide us, right?
Yes.
In which we have discussed about how the segmentation works, how the policy enforcement works now,
Okay.
right?
Right.
We have discussed about the ECMP, equal cost multipath, which can be achieved using the SDA Fabric. We'll discuss
Yes.
about it, that why we call it SDA Fabric. We'll talk about it later. And we have also discussed, that part in which we have covered about, can say,
Sorry.
host mobility,
First one.
right?
Right.
And network visibility.
Yes.
We also discussed about policy, or you can say automation and orchestration. Like in, you can say in traditional networks, we are making the configuration using the CLI.
Yes. That's great.
So you can say, 1 second. And we have also discussed about
Which features?
network automation and orchestration.
Orchestration. Yes. Yes. Yeah.
Network automation.
Yeah.
And
Writing on.
yeah, sorry. Because I'm open a new file or MS Paint file. Previous one is not working.
That's all visible.
Yeah. So you can see here, we were having like segmentation, policy enforcement, ECMP, host mobility, network visibility. We have network automation and orchestration.
Orchestration.
This we have covered in the last class. In today's class, we are supposed to cover the SDA fabric and its components.
Yes.
In this class, we'll talk about SDA fabric and its components.
Okay.
All right. So
Yes.
let me share that PPT. I'll share for SDA access. Can you see it?
Yeah, I can see this PDF. Yeah.
So now, what is SD access? I've given you the introduction in last class also, but here you can see that campus fabric plus Cisco DNA Center is known as SD access, software defined access. So what is SD access? GUI approach provides automation and assurance of all fabric configuration, management, and group-based policies. Cisco DNA Center integrates multiple management systems to orchestrate LAN, wireless LAN, and WAN means WAN access, wide area network access. So basically, what it is trying to say that in SD access, the network configuration will be automated using the DNA center. So first thing is configuration, second thing is management, and third thing is group-based policies. So what do you mean by group-based policies? Group-based policies means the groups will create using the SGT. Remember?
Yes. Yes.
We are using the ICE. Which feature of ICE? Cisco Trust Sec.
Yes.
So this is how we are going to create the groups, and on the behalf of those groups, we'll create the policies.
Yes.
Now, campus fabric. CLI or API approach to build a Lisp plus VXLAN plus CTS fabric overlay for your enterprise campus network. Now, what it is trying to say, it is see, SDA fabric having total 4 planes. Like I've told you in last class that a device is having 3 planes only: control plane, data plane, and management plane, right?
Management is a part of control plane, you can say.
Management is a plane of control plane. But right now we are talking about SDA fabric, not about a particular device.
Okay.
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 So
Okay.
SDA fabric is having total 4 components: control plane,
Okay.
data plane, policy plane, and management plane.
Okay.
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 Now, the control plane of the SDA fabric will be based upon protocol known as Lisp. We'll talk about in detail that what is Lisp. So Lisp stands for Locator ID Separation Protocol.
Separation. Okay.
All right.
All right.
Data plane of SDA fabric will be based upon VXLAN.
Okay.
Virtual Extensible Local Area Network means LAN. So VXLAN. It is very similar to VLAN, but there are other things also we'll discuss about it because VLAN is having some shortcomings. Policy plane. Policy plane is upon Cisco Trust Set. Right?
Okay.
And the management plane is taken care by DNA Center.
Okay.
What management plane is doing in normal device? So basically, management plane is related to the configuration using Telnet, SSH, HTTP or HTTPS. Plus, management plane was responsible for collecting the data, collecting the analytics, so that we can manage or we can take further decisions for the betterment of our network, right?
Yes. Yes.
Yeah.
Yes.
Yeah. So if we go back to the design, we see that campus fabric, campus fabric apply to a build to approach this VXLAN plus CTS fabric overlay for your enterprise campus network. Lisp, VXLAN, and CTS stands for Cisco Trust Sec.
Yes. Okay. Okay.
CLI provides backward compatibility, but management is box by box. API provides some automation by not conf, also box by box. See, Still, if you'll go to DNA Center,
Mhm.
DNA Center will be configuring all the devices one by one, not all of them together.
Yes.
This device will be configured separately. This device, this device, this device, this device, and this device, and this device. All right.
Right.
Now, as I've already given you the introduction of network architecture, in which we have discussed about two-tier architecture, right?
Right.
And we have also covered three-tier architecture.
Right.
And I've also told you that how the traditional network is working, right?
Yes.
So if we say that how it is working, so this is your distribution layer switches, here the core layer, and here you have the access layer.
Okay.
So basically, distribution layer devices are connected with access layer,
Yes.
each other, and they are also connected with the core layer devices.
Right.
So this is my C1, this is my C2, this is my D1, this is my D2, this is my access 1, and this is my access 2.
Right.
Access are now connected with each other, and we have
Yes.
users here.
Yes.
So by default, what we are doing, the network is segregated into two types of technologies. What do I mean by that? Here I'm running layer 2,
Layer 2. Right.
right?
Right.
So here I'm running the layer 2 part, which I'm running VLAN, trunking, STP, Ether channel,
Yes.
routing as well, but on the distribution layer switches. If we talk about layer 2 technologies,
Yes.
you can say port security, right?
Right.
So now, how the design is working, VLAN 10, VLAN 20, VLAN 10, VLAN 20. For inter-VLAN communication, we will create two SVI on distribution layer switches, SVI 10, SVI 20,
Right.
SVI 10, SVI 20. Now I'll say why you are configuring on both of the switches for the redundancy, or you can say for high availability, right?
Yes. Right.
But the problem is you can only assign one IP address to the end user as a default gateway. So for
Right.
example, in VLAN 10 we have 10.1.1.10, 20.1.1.10,
Right.
10.1.1.11, 20.1.1.11.
Right.
So in this case, we have to configure an additional protocol which is known as HSRP, or you can configure VRRP, or you can
Correct.
configure GLBP, Gateway Load Balancing Protocol, Virtual Router Redundancy Protocol, or you can say host standby router protocol. Okay.
Right. Right. Right.
Yeah.
Yes.
So then we'll have to enable routing over here.
Right.
Routing, right? We are supposed to configure DHCP as well. So you can configure these switches as DHCP server, or you can have a separate DHCP server in the network as well.
Yes.
This is how things are working. Now, this is about wired network.
Okay.
You also have the wireless, right?
Right.
So for wireless, you'll connect access points in the network first of all.
Yes.
Access points are always connected with access layer switches. All right.
Right.
AP, and AP.
Right.
Now, to manage those APs, we have a controller which is known as WLC.
Right.
So WLC is here from last, you can say 10 to 15, 20 years, and is working very like good, fine, great. So
Right.
now we are looking from the different perspective, like what we are requiring, what is the today's network are requiring, right?
Right.
In today's network, we are mainly, you can say, dependent on the applications, or our perspective is more like business, you can say business point of view. So we are growing
Okay.
by day, our expectations are also rising towards a network. So that's why we can't survive using these layer 2 technologies anymore.
Can you repeat it again?
See, in
Okay.
today's network,
Mhm.
right, the
Okay.
companies or the businesses are more dependent on the networks.
Yes.
Online communication, or you can say cloud adoption, is increasing. So our
Right.
network is having a higher amount of traffic,
Right.
right?
Right.
And we have a concept of BYOD, bring your own device. So in companies, you
Yes.
can bring your own device as well.
Right.
There are your personal devices, there are company devices, there are hundreds of things going on, right? So the
Mhm.
very first problem was the segmentation. How you will segment the guest user, how you'll segment the management user, how you'll segment the HR user, all of that thing.
Right.
Then they need to forward traffic. But the problem is we are running STP, spanning tree protocol. So spanning tree protocol will block one of the links.
Yes.
Then he'll say, okay, don't worry, we have the ether channel. Yeah, we have the ether channel, but it'll take time, right?
Right.
Or if you remember ether channel logic, ether channel does not offer you equal cost load balancing.
Yes.
So that's a different thing. But yeah, but in today's campus fabric, if we go to the campus fabric and we'll see the components. Okay. So you can see here, first of all, hmm, see Heather, you can see it, right? DNA Center is having two components, NCP and NDP. We'll talk about it. What is NCP and what is NDP. And you can see
Okay.
the eyes as well, right?
Right.
If you scroll it down, you'll see that you have a network represented using a cloud. Because we don't care about this network, nothing we care about is that DNA center must be reachable to all of these devices, right?
Right.
Now,
Correct.
this is we have border, which is known, B means border node, C means control node, and you have the S devices. All right, fabric,
O-
edge.
Okay.
Now, can you see this device?
Mhm.
What is this? This is WLC, wireless.
Okay. Controller.
And most of the time, every people is having one doubt in their mind, that why still we are using WLC, right?
Mhm.
DNA center can manage switches, routers, APs. That why do we need WLC anymore,
Mhm.
right?
Right.
I can put the capabilities of WLC inside the DNA center, but still in the SDA fabric, you will see that we have deployed a WLC. The only reason behind this is that WLC is here from last 20 years. So it is well developed to manage the access points, right?
Right.
So it would be like reinventing the wheel. We have a device who can manage the access point. So just make sure that you integrate that device with SDA fabric. Other things, please leave it on the WLC. All right.
Mhm.
So you will see that we can integrate WLC with DNA Center, but still to manage the access points or to push the configuration on access points. Can you see here down? We are still using
WLC
WLC.
solely to manage the access points, and
Yeah.
so
To
just to
manage
manage
access
that.
points only. What?
Okay.
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 Like we did with the ICE, we need the Cisco Trust Stack feature. So instead of creating on DNA Center, deploy an ICE and use that ICE with Cisco DNA. Likewise, we are doing with the controller. So you will see that controller is still there. All right.
Right.
Yeah. Now, in last class, Nitesh, I've told you about, or I've shown you the scenario of VPN. Remember?
Sorry.
VPN,
Scenario for?
private network, or you remember GRE, right?
Right.
This is R1, this is ISP router, this is R2.
Yes.
IP address of this is 101.1.1, IP address of this is 101.1.2, 201.1.2, and 201.1.1.1. This is your
Yes.
public IP address, all right?
Right.
And this is your private network.
Yes. Correct. I remember.
So IP address of this is 10.1.1.1 and IP address of this user is 10.1.1.2. IP address of this 21.1.1 and 20.1.1.2. Now what we were doing here, we were creating a tunnel interface from this end to this end.
Yes. A virtual tunnel.
So the virtual tunnel. So what we are doing basically, for example, this user is sending ICMP packet.
Correct.
In which source IP address is 10.1.1.2 and destination IP address is 20.1.2. When you give this packet to router will say, okay, the destination IP belongs to the site 2. So we have to use the tunnel interface.
Right.
A totally different story. But what R1 will do, R1 will
And the destination as 20.1.1.1.
R1 will encapsulate this actual payload with an additional header.
Right.
Known as GRE, generic router encapsulation, in which new source IP will be added
Right.
and new destination IP will be added. So when R1 will hand over this packet to ISP routers will see, okay, we have to forward the traffic towards 201.1.1.1. So ISP will forward it to R2. Then R2 will remove the outer IP header.
Right. Correct.
And then this is your actual payload. This is the actual payload. Right, in this?
Right.
In this case, this network, this one, yeah.
The ISP network will not understand the inside actual network.
This network will be known as
Underlay. Sorry.
underlay network.
Right.
And the GRE tunnel you have created is known as
Overlay.
the same concept we are trying to implying in a local area network or campus area network. Same thing we want to do with our campus area network, or you can say local area
Right.
network. So in SDA fabric, software defined access, we have overlay network and we have the underlay network. So if we go to the PPT, you'll see that what exactly is a fabric. What exactly is a fabric? First thing, wherever you see this word fabric means which network, Nitesh?
Okay.
Overlay
Fa-
network.
Okay.
Whenever you
It's
see
on.
that data center
It's
fabric, whenever you say that the wide area network fabric,
mhm.
fabric word is here to represent an overlay network. So you can see a fabric is an overlay. An overlay network is a logical topology used to virtually connect devices built over an
Give me a moment. One moment.
okay. So here you can see that overlay network is just a logical topology because the physical infrastructure is provided or offered by the underlay network.
Right.
So in an overlay network often uses alternate forwarding attributes to provide additional services and not provided by the underlay. Like in overlay, you can use GRE as I've given you an introduction. What is GRE? GRE is used in VPN. We have multi-point GRE as well. All right.
Yep.
This is used in DM
Right.
VPN. So
DMVP.
GRE provides point-to-point VPN and multi-point GRE provides point-to-multi-point VPN. Okay.
Correct. Correct.
We have MPLS or VPLS, the
Right.
WAN services. We
Right.
have IPsec VPN. We
Right.
have
CAP for wireless.
you know what is CAP web?
It's for wireless. It's for wireless technology. It is encapsulation for wireless.
Control and provisioning of wireless access points.
Okay.
So basically, like you said, yes, right. So we have the access points here. First thing access points will do when they'll come up, first of all, they'll always discover the WLC. Once they find the WLC, each of the access point will build a CAP web tunnel
Yes.
with their WLC.
Right. Right.
All of the access points will be building their separate CAP web tunnel with this WLC. And all of their data, control plane data, or the normal data will be going through the
Mhm.
CAP web tunnel. So basically, this CAP web tunnel requires an underlay network.
Right.
Yeah. And likewise, we have other protocols as well. Lisp will explore Lisp in our SDA fabric. And we have the ACI, which belongs to the data center. Okay.
Right.
Now, see, this is an overlay network. In this, we have the edge switch. We have switch number 2 and we have switch number 2. Sorry, 3.
Right.
This is what we are saying. But the actual topology is this, in which we have servers here, we have routers here, we have switches here, we have servers here. So basically, this is your underlay network, which is providing the connectivity between these three switches.
Right.
And by using additional encapsulation methods, by using additional encapsulation protocols, we are able to forward the traffic using the underlay network.
Right.
So why overlays? Why do we need overlays? Like if I ask you that why do we need Lisp here? Sorry, not Lisp, GRE.
we
Basically,
need to
yeah,
for GRE, we need to basically hide our network from the ISP.
yeah,
So ISP is not aware of it.
yeah.
To
And
do
second
that, we
is
can.
like you said, aware of. Because ISP don't having your private networks.
Right.
If you forward this packet directly to the ISP routers, ISP router is going to discard this packet, right?
Right.
It means overlay networks are adding something to our network. That's why it is asking us to the first question that why overlays? Separate the forwarding plane from service plane. IT challenges. What is the IT challenges? Network uptime.
Mhm.
IT challenges for business, network uptime for employees, new services. So now,
Okay.
simple transport forwarding, redundant devices and paths, keep it simple and manageable, optimize packet handling and maximize network readability. Flexible virtual switch services, mobility, map endpoints to edges services deliver using overlay, scalability,
Mhm.
reduce protocol state and flexible and programmable. As we see that our SDA fabric devices are flexible as well as they are easily to be programmed. You can create Python script, and you can program it or you can automate it using that script.
Okay.
So we have multiple challenges. That's why we have layer 2 overlays and layer 3 overlays. In layer 2 overlays, okay, we can talk about it.
Okay.
So layer 2 overlays emulate a LAN segment, transport Ethernet frames, IP and non-IPs.
Mhm.
So if I talk about it, we have two protocols in overlay. It is we
Okay.
have locator
Yes.
ID
Separation.
separation protocol,
Yes.
and we have virtual
Extensible protocol.
extensible LAN. All right.
Extensible. Yes. Virtual
So
extensible.
this is my switch 1 here, and I can say this is my underlay network. All right. I don't know what is the connectivity, how the things are working. Just assuming it that we have an underlay network. You have few switches here. One second. हेलो, अभी तो ऑफिस आया हूँ थोड़ी देर. छुट्टी है, मंडे की होती है. मंडे को होती है, मंडे को. हाँ, अभी आ रहा हूँ बस 11 11:30 11 बजे. 11:30 बजे तक आ रहा हूँ, घर पे ही है. यही मार्केट में मिलेगा यार. हम्म. ठीक. So this is my switch 1. This is my switch 2. This is my switch. So if a user is forwarding traffic from here to here, and I'm using Lisp as the overlay, all right?
Mhm.
So if this user IP address is, for example, 10.1.1.1, this IP address, user IP address is 10.1.1.1. IP address of this is A and IP address of this is B. So if you are forwarding ICMP packet again, source IP address is 10.1.1, destination IP address is 10.1.1.2.
Okay.
And Ethernet header in which you have the source MAC A, destination MAC B, and the type field. Once you forward this packet to switch 1, now this time switch 1 is not forwarding the traffic normally because we are using the concept of underlay and overlay. So if you are using an overlay concept, an additional header will be added with the payload, right?
Right.
We have seen in the GRE.
Right.
Now, he's saying about two types of overlays, layer 2 network, layer 2 overlays, and layer 3 overlays.
Right. Yes.
You forward this traffic further, a new Lisp header will be added. New Lisp header will be added. All right.
Right.
But you know what is the problem here? The Lisp will remove this layer 2 header. And this, only this information will be encapsulated with new Lisp. All right. That's why you will always see that in networks, we always give preference to virtual extensible LAN for data plane traffic, and we use a Lisp for only control plane traffic, not for the data plane. Because if you will use Lisp for the data plane traffic, Lisp will be encapsulating the payload, but Lisp will not allow you to encapsulate the Ethernet frame. Ethernet frame will be removed. But if you're using the VXLAN, this payload will remain same. And Lisp header will be added. Sorry, VXLAN.
Okay. Yes.
All right.
All right.
So that's why we call it IP to IP mapping. This is known as MAC to IP mapping. So in this scenario, I take you to the, okay, right now we don't, okay. When we'll explore the VXLAN and Lisp, you'll understand it better. But right now in layer 2 overlays, you can say that it transport Ethernet frame as well, IP and non-IP. IP and
non-IP.
Non-IP. But once you create layer 3 overlays cannot encapsulate non-IP packets. They always need IP packets there to encapsulate. Single subnet mobility layer 2 domain. See, like I said here, I want layer 3 between these networks.
Right.
No doubt, right?
Right.
But I want to keep up using the layer 2, or I want to use the concept of VLANs.
Right.
So these users' traffic needs to be encapsulated as they are transmitting it. There should be a layer 3 header, which is having the source IP, destination IP, layer 2 header as well. Please don't remove layer 2 header. So that's why we have two types of overlays, layer 2 overlays and layer 3 overlays.
Okay.
In which we have transport IP packets, IP version of 4 or IP version 6, but they cannot transmit.
VLANs.
You know how, when it will make sense to you, when I'll show you Lisp header and I'll show you VXLAN header, then this thing will make sense to you. All right.
All right. All right.
Next question, SDA access, fabric underlay, manual versus automated. Manual versus automated. Now we will need some time to understand this thing. See,
But just one question. You earlier mentioned SDA fabric is overlay. It is overlay, right?
yeah,
SDA
no
fabric.
doubt.
Now it's mentioning it's underlay.
Very good question. It is saying that SDA is an overlay, right? No doubt.
Yes.
But how overlay works? How overlay works? Overlay also needs the underlay network.
Right.
It is saying in that sense
Okay.
that how you will build underlay for the SDA fabric. How you will build underlay for the SDA
Fabric.
fabric,
Clear.
right?
Right.
So to build the SDA fabric, we have to build the SDA underlay. Only then the overlay will work. Yes or no?
Yes. Yes.
Yes. So now be with me and we need some time to understand this thing, that to build the underlay, SDA fabric underlay. SDA fabric underlay can be built using two methods. First is manual underlay. All right, Heather?
Right.
And second, automatic underlay.
Okay.
So if I say that this is my border node, I have few switches here. Then I have the access layer switches. A1, A2, A3, A4. So now, this is, for example, my border node. I'm just taking an example. We haven't discussed the SDA fabric terminology, right?
Right.
So I have to build the layer 3D network, like I said here in this topology. I'll not keep it as layer 2 now. I'll not keep it as layer 2.
It'll be layer
So
3.
what you have to do, Heather, sorry, Nitesh, you have to configure IP addresses over here. All right. You have to configure IP addresses over here. You have to configure IP addresses over here. You have to configure IP addresses over here.
Okay. So no more trunking.
Yeah,
It'll
no
be
more trunking, no more VLANs in between A1 and D1. No more STP. No Ether
okay.
channel.
So right now the edge devices should have a layer 3 capability. It should not only be limited to layer 2.
Yeah.
Okay.
Now, who is going to do this thing for you? You have two methods, manual and automatic. Either you configure IP addresses manually, then you'll have to configure an underlay protocol.
Yes.
So that A1 can reach to D1, A1 can reach to D2, D1 can reach to A2, and D2 can reach to A2. So in underlay, you have few options. First option is OSPF, and second OSPF is the option is ISIS, or third option is BGP, not EIGRP. See, you can say that EIGRP, but EIGRP is not preferred in networks because of its proprietary behavior.
Okay.
It was developed by Cisco, right?
Okay.
Yeah, everybody know that in 2013, Cisco announced EIGRP as an open standard protocol, but still it was developed by Cisco. So mostly vendors are avoiding it. So that's why you'll see that OSPF, ISIS or BGP. And mostly we are deploying
Yeah.
ISIS for ease of configuration and for other benefits. Okay.
Okay. Okay.
So if you go here and you see in this manual underlay, you can reuse your existing IP network as the fabric underlay. Key requirements. IP reach from edge to edge to border and control plane. This was the design, right?
Right.
So in this design, what it is saying that make sure while you are creating an underlay network, edge to edge must be connectivity there. Edge device must be connected to with other edge devices. Edge devices must be reachable to border. Edge devices must be reachable to control plane. All right.
Okay.
Make
So
sure
full
about
reaching.
all of these things while creating an underlay.
Okay.
Now it can be layer 2 or layer 3, but we recommend
Layer
layer.
3.
Can be any IGP, yeah, but we recommend it ISIS. So if you see this design here, sorry, this is the underlay network. You have to build it up so that these devices can reach to each
Yes.
other. All right.
Right.
You have to increase the MTU. Now you'll see that while we'll be doing the practical, you'll see that on 9300 switches, by default MTU is 900 bytes. Sorry, 9000 of bytes.
Okay.
But normally we have to increase the MTU. Normally it is, for example, 1500, right?
Okay.
As I have told you, Nitesh, while use the concept of underlay and overlay, so in overlay we will be using an additional protocol to encapsulate the payload.
Right.
To encapsulate that payload, that particular protocol will be adding few things, few bytes extra. So in that case, we have to increase the MTU. We'll see about it. And latency must be less than 100 milliseconds. So that's why you'll see most of the time we are using Gbps links, 1 Gbps or 10 Gbps link. All right.
Okay. Okay.
What it is saying that please make sure that from this edge to reach this edge, the latency should be less than equal to 100 milliseconds. It should not be more than 100 milliseconds.
Right. Correct.
Fully automated respective IP network underlay provision. Allow it most. You know how? Because I've done it in the past and that was amazing. See what I have in the lab. I have two 9300 switches. All right.
All right.
We'll see it. We have two 9300 switches. And I have two 3850 series switches. I've connected them like together this. Okay.
Okay.
So what I'm saying, I'm not making any configuration on this switch, and this switch. All of the underlay configuration, you'll see what you mean by underlay configuration. I mean IP configuration. And I mean ISIS configuration and few additional things. All right.
All right.
So now, if you have the proper licensing, if you have the proper supported platforms, So what you will do, this is your DNA center. All right.
All right.
And somehow DNA center is connected with my 9300 switch. This switch only, first switch. So in LAN automation, you have to onboard a device which is known as seed device. What do you mean by seed device? Seed device means that you need a device which is existing in the fabric. This is by default there, present in the SDA fabric. This is, for example, gigabit 0/1 and this is gigabit 0/2.
Okay.
All right. It
All
is.
All right.
Last thing I have to do is I have to onboard this 9300 switch to the DNA center.
Okay.
All right.
All right.
That's all you have to do here. That's all you have to do here. You have to tell the DNA center that this 9300 switch is the seed device. Is the seed
Device. So it's like the first device.
Yeah. And at the time of configuration of LAN automation on DNA center, you will be providing what? You will be providing DHCP configuration, NTP, server, SNMP server, SNMP credentials, SSH or telnet configuration. All right.
So these configurations you're going to do it on the DNS center.
This configuration is required. I'll show you why this configuration is required. You'll make this configuration, okay?
Okay.
And you'll use this configuration for LAN automation. So when you'll tell the DNA center to start the LAN automation, you'll see that this is your DNA. This is your seed device. Okay.
Yes.
This is your seed
Seed
device. So what DNA center will do? DNA center will push all this configuration to the 9300 switch.
Right.
And you know what? This DHCP configuration or DHCP pool is having an option 43. Is option
43.
Which is having the DNAC IP address. This is having the DNAC IP address. So all of the configuration will be pushed to this device. Okay. Now what is the requirement? This device must be a white slate box. Do you understand the white slate box means? White split means?
It should be just the plain device or
very clean device, no configuration. All right.
all right.
So you will boot this device, you will remove the configuration, and then you will reboot this device. You know what all of these devices do when they come up again? They start ZTP, which is known as zero touch provisioning, or you can use a term known as PNP, plug and
play.
So when you will boot this 9300 device, this 9300 device will do what? This 9300 device is by default configured interface VLAN 1 and IP address all right,
by default.
By default, if this device supports the PNP, plug and play. So this device will send a DHCP discover message. Now we have already configured the seed device, right?
Right.
There are few other things are also happening at the same time. So 9300 device will say, okay, now we have a device. Now we have a device. So what 9300 switch will do? We have already given a DHCP pool to it. NTP server, SNMP credential, SSS, telnet configuration. So 9300 device will push that configuration to this device. Okay.
Okay.
We'll push that configuration to this device.
Okay. What all the DNA center had given it?
Yeah. Everything.
Okay.
And this DHCP option 43 is also containing what? DNAC IP address.
Clear.
So whatever the IP address of your DNA center will be given to this switch, will be given to this switch.
The downstream switch. Okay.
Yeah. Now this switch will discover the DNAC and it will automatically register itself to the DNA center. It will automatically register itself to the DNA center. And you will see that this device is configured with ISIS automatically. You'll see ISIS neighborship automatically between these 9300 switches. Okay.
Okay.
Yeah. So just a second. $92, $168, $4.0.
Okay.
DNS help is, I think, not up.
Okay. Okay. You're putting another screen. Okay. Right now it's still the notepad.
Yeah, I'm just accessing the server. See.
Okay.
Yeah, DNAC is power off. So power it on. Will boot. Okay. Then I'll show you the LAN automation things. So LAN can be automated, fully automated. Okay. It is.
Okay.
I can tell you how I felt at that time when I've configured the LAN automation. It was like, you can say, like a cakewalk. I have to configure a few things on DNA center. You have to tell the DNA center that who is the seed device, right? And leave it. Seed device configuration, sorry, the configuration will be pushed to the seed device. Now your responsibility is to bring up this device as a white slate or clean slate.
Yeah.
So this device should not have configuration. Okay.
Right.
Once you'll do this, you'll see this switch is automatically sending the DHCP request, PNP discovery. It will automatically find the DNAC. It will automatically register itself to the DNAC.
Right.
ISIS configuration is pushed over there, SSH configuration, SNMP credentials, everything.
Right.
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 So you can see that key requirements. Leverage standard PNP for bootstrap. Assume new erased configuration. Okay. And uses a global underlay address pool. Now I'm not digging it this thing much. Why? Because you will not be able to understand it now. That at the time of LAN automation configuration, you have to tell the DNAC that this is your seed device, right? This is your 9300 device. This is your 3850. This is your 3850. So you need to push IP address here, 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 and here, right?
Right.
So for that configuration, sorry, IP configuration, you need the IP addressing range. Yes or no?
Right.
That is known as global pool. That is known as a global pool.
Okay. Right.
Key consideration. What is required? What is required? Seed device pre-setup is required. All right.
Reset. Okay. The seed device must.
Yeah, you have to onboard the seed device manually,
Okay.
because you know that why we are afraid of automation, because we know that it will require less workforce, but still we require those people who can do this thing. Like, what is the requirement now? Seed device must be pre-set up. Who will do this? Us.
Right.
Because we will bring up that seed device onto the DNA center. We'll tell the DNA center that this is the seed device. Afterwards, the seed device will automatically discover the underlay devices. Automatically configuration will be devices, and you'll see that okay, our LAN is working now. So the prerequisite is LAN or seed device must be pre-set up. Okay.
Right.
Yeah.
So basically, the C device, you need to make like some configurations needed. The
Yeah.
IP configuration at least.
Multiple things are needed. See,
Mhm.
DHCP configuration, tool, NTP server, SNMP credential, SSS tenant. I'll show you. I'll show you. Okay.
Okay.
Yeah.
Oh,
Because you know that in networking we have two aspects, theory and practical. So few things can be seen as practical.
Mhm.
Describe Cisco SD access architecture, fabric, components, and terminology. Right? If you have seen on
Right.
the above topology, I've shown you that control plane box. This is my border node. This is my edge node. So
Right.
if you see that the fabric components and terminology, here on the above section, we have three things.
Okay.
We have network automation, simple GUI and API for intent-based automation of wired and wireless fabric devices provided by DNA Center. Network assurance, data collectors analyze endpoints to application flows and monitor fabric device status. Okay.
Okay. So
And
the network assurance, that component, it does the analytics sort of.
it does the analytics. Yeah.
Okay. Okay.
Now, here, if you come to the LAN fabric now, here we have fabric border nodes, B, right?
Okay.
We have fabric control plane nodes. We have intermediate nodes to build the underlay. Okay. Those devices are not part of the SDA fabric, because SDA fabric is an overlay network. But to create that overlay network, we also need some underlay devices. So we have the intermediate nodes, also you can say underlay. Then we have fabric as nodes. Fabric.
Edge nodes. Edge nodes.
Because why we call them as nodes? Because they are connected at the boundary.
Right.
But the end user is introduced in the network. So your end user will be coming to the edge devices. First of all, edge devices will authenticate the endpoints, and edge devices will provide them the required connectivity. All right.
Okay.
And we have fabric wireless access points.
Right.
So now if I give you just an overview of this topology, So this control plane node, what this control plane node do? We will build a Lisp session with control plane node. This session? Lisp. Okay.
Lisp. Okay.
And I explore it individually that what does it means. But control plane nodes are configured with Lisp, locator ID separation protocol. And in Lisp, we have few roles. Okay, Nitish?
Okay.
So the control plane nodes will be playing the role of map server and map resolver. I'll take into it later on, but for now, just remember that your control plane nodes are Lisp enabled, and they have many roles in Lisp. And map server and map resolver roles are played by the control plane devices or control plane nodes. Okay.
Okay.
Fabric border nodes. Why do we call them border nodes?
This is also in the boundary. The first, it's like,
Yeah, see, if I ask you Nitesh, I have to go to internet, right?
right.
Internet is my part of my fabric.
No,
Is internet part of my fabric?
no, it's not part of your fabric. It's
Right?
not part of
Internet is
Right.
not part of my fabric network.
Right.
If I have to go to other networks, I have to go to, for example, data center. That is not part of my fabric.
Fabric. Clear.
So how we will get out of our fabric? We'll get out of our fabric using the border nodes. So whenever we need to reach the devices who are not part of our fabric, we have to look after border nodes. We have to look up to them, that we have to go outside of a fabric. Tell us how to reach there. So fabric border node will say, okay, give it to me and I'll forward that traffic further. Right?
Right.
So now I'll show you in coming few slides that we have multiple types of fabric border nodes. We have few types of fabric border nodes as well. Okay.
Okay.
Then we have fabric as devices. If you want to give it a read, see, a fabric device that connects external layer 3 networks to the SD access fabric. Okay.
Okay.
Then we have fabric as nodes. A fabric device access or distribution that connects wired endpoints to the SD access fabric. Because we have two types of technology or two types of network devices or the users. A user who is asking for the wired connectivity, or other user may be using the Wi-Fi or wireless.
Right.
So what is the role of fabric as nodes here? The fabric as node is providing the connectivity to wired endpoints to the SDA fabric. Like we have a printer, we have a server, we have desktop, we have biometric machine, we have scanners, and we have access point as well, because access point is not directly connected with the border node. Access point is also connected with the fabric as nodes.
Right.
Okay. And then we have the fabric wireless controller. So fabric device that connects fabric APs and wireless endpoints to the SD access fabric. Because this is your access point and users are connected with this access point, right? We can represent wireless like this. So the WLC is doing what? WLC is providing the connectivity to the access point as well as to the endpoints to SDA fabric. Okay.
Right.
Now it will give you a close look to the SDA control plane nodes. Yeah. Now I'll show you what is Lisp. Control plane node runs a host tracking database to map location information. Nitesh, do one thing. Please give it a read. Read the points.
Control plane runs a host tracking database to locate map location information. A simple host database that maps endpoint IDs to a current location along with other attributes. Host database supports multiple types of endpoints, IDs, lookup such as IPv4, IPv6 or MAC. Receives endpoint ID, map registrations from edge or border edge nodes for known IP prefixes. Resolves lookup request from edge and or border nodes to locate the destination endpoint IDs.
Now, I understand that you didn't get anything, right?
Yes.
Yeah. So, yeah. Let me take you to the traditional networks.
Sure.
This is R1. This is R2. This is R3.
Okay.
This is a switch. This is a user. Network of 10.1.1.0/24 is running here. 12.1.1.0/24. 23.1.1.0/24, and here I'm running 20.1.1.0/24. Now by default, each router is having their own routing table.
Okay.
10.1.1.0/24 is directly connected. 12.1.1.0/24 is directly connected. R2 is having two networks, 12.1.1.0 and 23.1.1.0, right?
Right.
And R3 is also having two networks. 23.1.1.0/24 and 20.1.1.0/24. Now, if this user wants to reach this user, by default, it can't, right?
Right.
So what you have to do,
Right.
you have to configure static routing or you have to configure dynamic routing. That's your personal choice, right?
Right.
But somehow you have to provide the routing information to each and every router. So I'll configure this router as that 20.1.1.0/24 is reachable via 12.1.1.2. I'll talk about two networks that in order to reach 10.1.1.0, you can forward traffic to 12.1.1.1. And to reach the 20.1.1.0/24, you can send traffic to
23.1.1.2.
I'll go to R3 and I'll configure that in order to reach 10.1.1.0/24, you can send traffic to 23.1.1.1.
Correct.
If IP address of this user is 10.2 and IP address of this user is 20.2, this user will generate a packet source IP as 10.1.1.2, destination IP address as 20.1.1.2. The traffic of the packet will be given to router. Router will check its routing table. Router will say, okay, this particular user belongs to this subnet. So we can forward traffic to R2.
Right.
This packet will be given to R2. Then R2 will see its routing table and R2 will see this traffic, will give this packet to R3. And R3 will hand over this packet to this user. This is how the routing works, right?
Right.
This is how the routing works in normal scenarios.
Correct.
But this is not scalable solution, Heather. Sorry, Nitesh.
Okay.
This is not a scalable solution. You'll say why? Because we are not talking about the ISP networks here. In ISP network, I can have millions of networks or millions of IP subnets, right?
Right.
So what we are doing? We are advertising that subnet directly to all the routers.
Correct.
We come up with the concept of Lisp. Now, you know what Lisp is doing? I'm just giving you an overview. This is R1, this is R2, this is R3.
Mhm.
This is R1, this is R2, this is R3. Now, I am not going to advertise this subnet to R2 or R3 because then I don't know they required it or not, right? Why should I advertise a prefix if they haven't asked me? So by default, we are working on one model which was known as push model. Push model means you want it or not, but I'm still advertising it to you. It is your choice if you want to filter it. Please configure route filtering. Yes or no, Nitesh?
Right. Right.
If I am running EIGRP between two routers, R1 will advertise all the prefixes to R2.
Right.
R2 personal choice. If R2 wants to filter a prefix, R2 can configure route filtering.
Right.
But now with the using Lisp, we are moving towards pull model. We are moving towards pull model. Pull model means that I'm not going to advertise the information to R3 or R2. What I'll say, I have few roles in Lisp. And one role is map server or map resolver. And we have a term known as RLOG. RLOG stands for route locator.
Locate.
So what I did,
Okay.
I've created a loopback on R1. IP address is 1.1.1.1. I have also created a loopback on R2, 2.2.2.2. You know what I'll do here?
Okay.
I'll tell them that,
Mhm.
for example, 10.10.10.10. That 10.10.10.10 is map server for you guys. It means what they will do, R1 will register that 10.1.1.0/24 is reachable via 1.1.1.1. So I am using 1.1.1.1 as route locator.
Locate. Locator. Okay.
It means in order to reach this network, you can take help from 1.1.1.1. And what R3 will do, this IP address will be used as, so R2 will register to the map server that 20.1.1.0/24 is reachable via 2.2.2.2. This is known as RLOG plus IP mapping. This is your switch one. Now we have a user here. Right, Nitesh?
Okay.
IP address of this user is 10.2 and IP address of this user is 20.2. Now this user wants to reach 20.2. Source IP address is 10.2, destination IP address is 20.2. This user will forward traffic to its default gateway, means, right?
Yes.
So what R1 will do here? Now I've told you like two things, map server and map resolver. A single device can be performing both of the roles, map server and map.
This one.
So I've told R1 that map server is who? 10.1.1.2 and
Then,
map resolver is also 10.1.1.1.10.
okay.
So when R1 will say, oh my God, okay, in order to reach 20.2, I don't have any route. I
So
don't have
send it
any
to the map.
route. So what R1 will do, R1 will send a map request.
To the map server.
Or you can say query. That
Okay.
I want to reach 20.1.1.2. R2 will say, okay, this subnet is reachable via.
2.2.2.
It will forward that query to R3. R3 will respond to R1. R3 will respond to R
What?
that 20.1.1.0/24 is reachable via 2.2.2.2.
Okay.
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 Now how it will help? Switch will forward this packet to our router, and what router will do now? Router will say 10.1.1.2, 20.1.1.2, and who is the source?
So this is
And who is the
1.1.
route locator? 2.2.2.2. So
Yes.
you see now, a router will having the information of the required prefixes only. If it needs to reach somewhere, it will ask to the map server, map resolver, that do you have any information about this subnet? Do you know who is the route locator? Do you know who is the route
1
locator?
minute. Just give me 1 more 5 minutes. 5 minutes.
Yeah, we'll wrap it 10 minutes.
Okay, just give me just 5 minutes. Just 1 minute.
Okay. So you can see this, okay? And now we go back to this. See, and it is.
Okay.
See, we will be configuring a loopback on each and every device. You'll see it later on.
Okay, but this one also will be if it's automated.
Yeah, it can be automated.
Okay, automatic underlay can be done.
That's why it is required, right? So, like it said that as devices must be have reachability to the control plane already. R1 1.1 must know that how to reach 3.3.3. Now, this as is having a user IP address is 1.2.3.4/32. You'll say how /32 because /32 represent a single device.
Okay.
/32 represent a single device. Okay.
Okay.
Yes. So what this edge device will do, whenever this user will connect to the edge device, we have already configured the list, right? So
Right.
this edge device will send a message to map server.
Right. Right.
That 1.2.3.4/32 is connected with me. So if you need to go to 1.2.3.4, you can send traffic to 1.1.1.1.
So this is registration, like map
Yeah.
registration, you can say that process.
Map registration request, yes. So you can see IP to RLOC 1.2.3.4 is the user, and FE1. Why it is given FE1? Because it is giving you the just name. But see, RLocator is IP address. Okay.
The loopback.
Yeah. I've used loopback. You know that if physical interface will goes down, loopback is still up.
Right.
Yeah. So you can do IP to RLoc mapping, in which you'll give this IP with this are located to the control node. You can also do the MAC to RLOC mapping. In MAC to RLOC mapping is you have the MAC address of this user AABBCCDD, and you use 1.1.1.1. So using 1.1.1, you'll register the MAC plus RLOC IP to the control node, or you can do which is required in R. We need the MAC address of other users. So 1.2.3.4 is binded with this MAC address.
Right.
So what control plane node do? Control plane node is doing what? Control plane node is keeping a database.
Right.
In which it is having the information of each and every host. This time we are not, you can see we are not focused on the network itself. We are focused on the endpoints.
Right.
Focused on the endpoints.
Endpoint.
So control plane node is having a simple host database that maps endpoint IDs to their current location along with the attribute. Host database supports multiple types of endpoint ID lookup types, IP version 4, IP version 6, or MAC. You can find out a user on the basis of MAC address, on the basis of IP version 4 address, or on the basis of IP version 6 address. So let's support MAC, IP version 4 and IP version 6. Okay.
Right.
Receives endpoint ID map registration from the as and or border nodes for known IP. So this is your as node. Whenever a user will be connected to this as node will send a map
request, map registration request
to the control plane node. Resolve lookup requests from as and or border nodes to locate destination. See, if here a user who wants to reach 1.2.3.4, so this as device will send what? This as device will send a lookup request.
Right.
That I'm looking for the route locator who can help me to reach 1.2.3.4. 1.2.3.4.
Right.
Okay, this is clear. What is the role of control plane node?
Right.
So after getting the information that in order to reach 1.2.3.4, you have to go to 1.1.1.1. So who is the source locator? 4.4 will become the destination 1.1.1.1. All right.
Right.
This is the responsibility of control plane. Now, who can be implemented as the control plane node? Like the platforms. You have 9300 catalyst switches. You have 9400 catalyst switches. You have 9500 catalyst switches. You have 9600 catalyst switches. All right. Yeah.
All right.
But I also like 6K, 4K, ASRK, 1K. So if I write it down here, control plane nodes, platform. Sorry. 93, 94, 95, 9600, 35, we have 3K. In 3K, we have 36, 50, and 38.
3850.
Okay.
Okay.
Then we have 6K. In 6K, we have 6500 and 6800.
Okay.
Or we have ISR.
4000 series.
All right.
Okay.
And then we have ASR.
Okay. Yes. Okay.
ASR 1000, 1000 HX, 1 or 10 gig port with RJ45 or SFP. Okay.
Okay.
In ISR, we can have virtual router as well. Virtual routers can be installed on an ESXi server.
Okay.
All right.
All right.
We go to the internet, we can search for other platforms as well. SDA, Fabric. Control plane load.
We are on an. Can you share that screen?
Yeah, basically, I'm just looking for the platforms. So I'll share the list with you.
Okay.
But all of these devices can be configured as control plane. No.
All these devices can be.
Yeah.
Okay.
And you can say DNA Center compatibility metrics. So let me share the new screen.
So right now, this table, this control plane, the table, the map server table,
Now
we
you can
can see there is a display for this. We can as a administrator we can view it this table.
now can you see the browser?
Yeah, you can see I can see the browser. Yes.
Do you have the DNA versions? Which version you are running right now? So for example, I choose 1.3. That select the device. I said I want to check the switches.
Yes.
For Cisco SD access.
Yes.
You upgrade 1.3.3. For example, 0. For any version, device role. I said I want looking for fabric, border and control plane. Okay.
Okay.
Now you can see fabric, border and control plane. You can have this list. All of the devices are given here. So there was an option to download this. Please.
Okay.
No issue, but Control A, Control C. Let me share in the chat box. You can reach to this link and you can check the supported platforms. All right.
All right. All right.
This is at the time of onboarding. When you are onboarding a device, you can give it a role. Is it a control plane node? It is a border node, or it is a as node. All right.
All right.
Then we have the as nodes. We have SD access platforms for as node. So if you go to the as nodes and you can see it as node. As node provides first hop services for users' devices connected to a fabric. Responsible for identifying and authenticating endpoints, because the user will always be introduced at the access layer, or you can say as devices first of all. So as device will authenticate that user using the 802.1x method.
Right.
Register specific endpoints ID. Whenever new device is added to the as it will register it to control plane using Lisp map registration, right?
Right.
If it is IP version 4, it would be /32. For IPv6, it would be /128. Provides an anycast gateway for the connected endpoints. Just give me 1 second. Hello. बस आ गया, अब 5 मिनट में आ गया, 5-10 मिनट चला जाएगी, बस 10 मिनट रुक जाए. So provide an anycast layer 3 gateway for the connected endpoints. See, here we will see the same IP address for all the users. User, wherever user can go, user will always see that the default gateway IP is same. Okay.
Right. Right.
Perform encapsulation, decapsulation of data traffic to and from the connected endpoints. See, if the end user will give it traffic to the as node will encapsulate that packet either with Lisp or with VXLAN. Okay.
Right. Right.
And you have them SD access 92,000, sorry, 9200, 9300, 9400, 9500, 9600, Catalyst 3000, 4500, and Catalyst 6000. Okay.
Okay.
All of these platforms are your as nodes, and at the time of onboarding, you can give it a role as node.
So right now, earlier in traditional network, we can say that the gateways, the VLAN gateways used to be in the distribution switch.
Yes.
Now it will be in the edge switches itself.
Yeah, that's why you will see that in new deployment, we don't require HSRP, GLBP, or BRRP.
Right. Yeah.
Okay.
Okay.
Yeah. So you can see that.
So it's basically like the user VLAN is in the gateway itself is in the edge switch. Yeah. Clear.
The gateway is limited to the as nodes.
Okay.
Likewise, VLANs. Okay.
Okay.
Yeah. And you can see the platforms 9200, 9300, 9400, 9500, 9600, 3000, 4500, and 6000. Okay. And at the time of onboarding, you can give it a role as node. In next class, we'll discuss about border nodes and all that stuff. Okay. I think that's enough for today. Any conclusion here?
I'll clear it. I'll clear it by next week, before the next class. Just prepare some questions, so it'll be better.
All right, I'll upload videos. Okay.
Sorry. Yeah, sure.